In today's video, we have a look at DeepSeek, the open source AI model from China, which has perplexed all the big players in the AI space. And in this case, we want to run it locally and see whether it can live up to expectations. So this just means that at first you can see here, you can find, of course, the GitHub repo of them, and there you can find additional information. And also you can see here the benchmarks, right? And those benchmarks are quite impressive because, as I already said, it's an open source model. So you can use it, you can run it on your own hardware if you want to do that. And it's almost on par, or even sometimes maybe a little bit better or a little bit worse, to the best models out there currently. The commercial models from maybe OpenAI, for instance, and other kinds of options. You can see it up here, right? The O1 model. Now, the question, of course, now is it really that good? Especially if we run it locally on our own hardware, because there we always face limitations. We need to be aware of that, right? We cannot run the biggest model they have probably on our own hardware. This is probably not feasible for most of us. So we would have to use a quantized version. And this is exactly what we're going to explore here. And there are various ways to run this. And the first one I'm going to show you, let's just go to, in this case, my terminal. As you can see here, there I have various models. So I've installed them by Ollama. You can install Ollama software and you can download the models. And you can also see here the model size. And there, for instance, I have here DeepSeek R1 with the 7 billion parameter. So it's kind of not the smallest size, but I think the second smallest size. So it's quantized, of course, which means that normally, of course, it loses a little bit of performance. But this is much more interesting to us, right? Because this is probably the version which most of us would run locally. Maybe the 14 billion, but even then it might make more sense if you have a GPU and maybe a little bit better system. So let's just use this one here as an example. And if you want to run it in your terminal, it's kind of simple because all you specify is Ollama run. Right, and then you specify the model. In this case, it's a DeepSeek minus R1 double point and then the 7 billion parameter version. And if I do that, just a second, and then I can ask my question here, right? So here you can see, send a message, and I say, what is Andromeda in space? So that's my standard question always, which I send. So if I enter this, you can see that now it starts thinking, okay, so I need to figure out what is Andromeda, and so on, and so on, and so on. And I can see there's a galaxy that's probably already right, correct. And then you can see there's the answer, right? So Andromeda, also known as Messier 31, M31, and so on. It's a spiral galaxy. That is correct. The other things, I'm not sure, but this is at least correct. So it looks good, and also kind of interesting that it explains the thinking process, right? As you can see here, it's think, and it explains exactly the way it thinks. So how it derived the solution, which I always wanted to have with the O1 model as well. So hopefully OpenAI will also implement this because it's much more transparent. It's kind of interesting to see what the model is actually thinking. So, of course, this is maybe not the best option to run for everyone because not everyone wants to use the terminal for that. And of course, that's why I also created a little Streamlit application in Python, which you can find here. So let me just show it to you. This is the Streamlit application itself. So if you're interested, just let me know. I can also, of course, give you access to the code if you want. But the idea is that you can see here we use the same model and we use the Ollama package, and this is what we run. And we run it now in a nicer interface, which is this one here. And for that, I already prepared a specific question where the model needs to think a little bit more, and we're gonna challenge it and see whether it can actually solve this solution. So let me just paste it inside, and then let me just read through it so you can also see the actual question. So it's about a detective is investigating the theft of a valuable diamond. The only information available are the following clues. So there are 3 suspects, which is Alex, Bella, and Chris, and one of them stole the diamond. And now Alex says, I didn't do it, and Bella has the diamond. Bella says, Chris has the diamond, but Alex is not telling the truth. And Chris says, I didn't steal the diamond. And now if exactly one person is telling the truth, who stole the diamond? Explain your reasoning step by step. Okay, that's my question. So the model, in this case DeepSeek, the 7 billion parameter model, we need to be aware of that, but it should solve this specific case for us, right? So now we just run it, and then we just see, okay, let's start thinking, and let's see what it comes up with regarding the solution, right? So you can see it starts actually now generating some text, and continues, and let's just see and wait until it's finished. So obviously it is finished. And the result is that Bella is the thief or the culprit. So is this true? You might write it in the comments if you agree with the model or not. But let's have a look one more time at the original query, right? So here we say exactly one person is telling the truth. So that means that 2 persons are lying, right? So if Alex is lying, let's say Alex is lying, I didn't do it, and Bella has a diamond. So this, if Alex is lying, that could mean that he really didn't do it, but Bella has not the diamond. So then Alex would also lie, right? If Bella says Chris has the diamond, but Alex is not telling the truth, so that would work actually. So if Alex is not saying the truth because he say, I didn't do it, this is correct, but Bella has the diamond, this is wrong. So then this would be wrong. Bella would be right, Chris has the diamond, but Alex is not telling the truth. This is true because he says that Bella has the diamond, which is not true. And then Chris says, I didn't steal the diamond, and Chris is also lying, because only Bella says the truth. This would mean that Chris has the diamond. And if that's the case, and you agree with my conclusion here, that would mean that this statement here, that Bella is the thief, is actually wrong. So please write in the comments if you agree with me, or if you see it differently regarding this specific statement here. But I think that actually this is not the correct answer, but instead Chris should be the correct answer. Now, just to summarize this one more time, that does not mean that the model itself is bad, right? Just because in this case I think the model is wrong. The model itself is astonishing, right? Regarding all the tests and so on. The point I want to make is that if we quantize a model, and it doesn't matter if it's this DeepSeek model or if it's any other kind of model, of course then the model performance shrinks. And in this case you've seen, for instance, this specific query, the model could not solve on its own. In the 7 billion parameter version. And by the way, I also tried this in ChatGPT, and ChatGPT was able, in the 4.0 model, was able to give me the right answer on the spot. So of course, it's not a fair comparison, right? Because here we have a local 7 billion parameter model and not the full capability of the DeepSeek model, which is available, of course, right? Probably it could also solve this. But one more time, the point I want to drive home is this running it locally is not the same as running it in the cloud with all the compute resources. That's what we also have to keep in mind here, okay? So that's it for this video. Hopefully you enjoyed it. Again, if you do not agree with me, please write it in the comments. Also, your feedback, if you have used it already, let me know. Otherwise, if you have not subscribed so far, please subscribe to the channel. You support me in this case, and then wish you all the best, and hopefully see you in the next video. Until then, best guys.